Indian agriculture operates on a staggering scale, yet it faces a persistent and worsening labor shortage. Traditional crop spraying relies on manual workers, a method that leads to significant chemical waste through drift and overspray. The physical toll on these workers is high. Carrying heavy liquid tanks across uneven terrain in the heat results in inconsistent coverage, exposing the environment and the farmer to high concentrations of pesticide. A high-tech intervention is now appearing in this landscape, the Meghdev Drone Station. Constructed from corrugated steel and powered by advanced solar arrays, these modular hubs stand out against the raw dirt of the surrounding fields. This structural juxtaposition represents the moment aerospace engineering reaches the most isolated and resource-starved corners of rural India. A farmer initiates contact through the station's multilingual digital kiosk, ending their technological isolation. The kiosk accesses an advanced AI-generated replica of the farmer's specific land, a concept known as a digital twin. The system tokenizes physical farmland into measurable units. The smallest, the pixel, measures 1 square millimeter, allowing AI to detect leaf-level diseases like these brown spots. The larger tile unit is GPS-enabled and stored on a blockchain, creating an immutable record for every operation. This interaction links an isolated farm to a decentralized, blockchain-powered intelligence matrix. This single village station is one node in a massive nervous system. To manage millions of acres, the network uses a 4-tiered hierarchy. This structure allows the company to scale its physical infrastructure from individual villages up to the district level. At the grassroots, Tier 2 house centers act as local hubs, while Tier 3 Viego centers manage larger block-level territories with integrated electric vehicle support. Tier 4 drone stations utilize multiple ISO containers for high-capacity work, while Tier 5 FAME hubs coordinate drone traffic across entire district grids. This rigid, area-based tier system provides a scalable way to organize the logistics of modernizing remote Indian farmland. When a kiosk order is processed, it triggers an automated response at the local station. Specialized container modules facilitate rapid battery swapping and chemical payload loading. The mechanical sounds of automation signal that the flight is being prepared. The Viego agricultural spraying drone is the high-capacity hardware designed to execute these missions. It features multi-directional obstacle avoidance, weather resistance, and a payload capacity of up to 70 liters. This sequence translates digital AI planning into physical agricultural action. Strict safety protocols occur before flight, including an ADS-B beacon ping to clear the local airspace. The drone lifts off and navigates autonomously using centimeter-level RTK positioning technology. For the farmer, the result is a massive reduction in chemical waste and the end of hazardous manual labor. Beyond spraying, the flight data enables predictive yield estimation and allows farmers to connect directly with crop markets through the platform. By removing middlemen and cutting input costs, the station provides the farmer with direct economic empowerment and increased profitability. The station continues to operate via its rooftop solar arrays, remaining self-sustaining and off-grid. Ojas Aerospace is building a decentralized infrastructure grid to democratize deep tech at the grassroots level. This network is a physical component of the national initiative to achieve a fully realized digital Bharat by 2030. By anchoring aerospace technology in rural soil, Meghdev drone stations integrate isolated farmlands into a coordinated, data-driven network that spans from the individual leaf to the national district.